Everybody. My name is Pablo. I am with Bldrs.ai. I'm going to talk about our experiences in IT and what we learned about open source and how people work together to do big things by collaboration. So a little bit about me. I was doing startups back in the early 2000s in tech and eventually joined up at Google. And around 2010, they used to have one day a week you can do what you want. And so we all pitched in to help with the Haitian earthquake response out in New York City, Google. And then during that, I met this group called Architecture for Humanity, who was doing open source architecture pro bono with operations around the world. They had won the TED Prize for the best idea of the year back in 2006. And we're in Haiti helping out rebuilding after the devastating earthquake there. That was part of the inspiration for creating a new group at Google called Crisis Response that basically tried to bring more and more technology into the open source world, GIS. We made a project called Person Finder to help find lost loved ones. And kind of starting at that moment, I became very interested in what was going on in the rest of the world outside of IT, and how open source might be, principles, collaboration might be applied. I spent all the teens until about 2018 there and worked on GTLDs, which is the top-level domain registry system. We open sourced that, the Nomulus project. And also the AI group eventually that created transformers. I didn't do that personally, but I was in the team that used that at Google. And we do have kind of an AI in our name. Oops. So I want to. We created a company in 21, 22 called Bldrs.ai, and the idea was to kind of take the principles from IT and see how we could bring them to AEC. Some friends in Zurich had a property development company, that they were doing kind of greenfield development from unmanaged plot all the way through to managed building. And my discussions with them very much sounded like the prototype of tech could really improve the way that people were working, if only we could figure out how to use the practices that we were used to. So large collaborative distributed teams, working across company, cross agencies. How do you work together, like share a link instead of send an email with an attachment? How do you change a project over time without doing versioning with the date in the file name on the D drive, things like that. And so we figured these things out in IT, but we haven't really seen that kind of process adoption in AEC. I bring this up. This is called a code galaxy to give a feel for what we take for granted in IT world. Here is a live surf through WASD keys. So this is all the npm packages on GitHub. This is each dot represents a package. So if I can find one and click on it, this is like TC React fancy component. So it's all React as expected. There's just millions and millions of projects. Each one of these projects has its own contributors. There's like a little bit of blue lines that you can see showing how they all link together. In comparison, that's all the NPM ecosystem. Let me come back into this. If you look on GitHub, you look for tags like AEC, hashtag BIM. It's an extremely small sliver of the projects. So IT over the last 20 years has completely converted to an open source stack. But AEC is far behind that, and everybody, I think, knows that. The real signal for us, and part of thinking about starting a company, was the open letter to Autodesk. I don't know if anybody ever heard of the open letter to Autodesk? Yeah, back in 20, and then they followed up a couple of years later. Hey, you guys didn't really improve, and so let's look at startups in the field. That little sliver of 1% is how much open source there is that is kind of described as AEC. I'm sure there's more usage, but. So kind of one of the key lessons here is that we did figure out a way for even competing companies to mostly collaborate in the IT space, and this is the open source ecosystem there, and we should be shooting for something like that in AEC, the built world, other things. There's fintech, there's health tech, there should also be prop tech that works with these kind of principles. This is our site, Bldrs.ai. You can type it in or go to our cool QR code. It is very much in collaboration with the ideas that Antonio was talking about. We forked WebIFC about 1.5 years ago to kind of build an engine that was ready for kind of the Figma thing of like real-time collaboration. I'll talk about that more in a second. And we have that stood up now. We've kind of been heads down for the past year. I've known Antonio for a while now. Tom Ben Diglin, a bunch of the people in this space, I think, are really doing awesome work. And what we're trying to do is kind of bring some of the, not the geometry so much, like that started and we handled, but the kind of connection to the other types of infrastructure, so like Git, and kind of doing things at higher scale. Let me talk a little bit about what our engine looks like. So this is very much like Antonio's slide about most of the code that you want to use in these projects should be open source. We should not be reinventing the wheel. We use the iceberg analogy. We're focusing on the very bottom of the stack. And we call our fork of WebIFC Conway. It comes from Conway's law that says your software reflects your organizational structure. And so we are a distributed group of developers around the world, and we wanted to make the software kind of respect the new emerging social networks of like kind of Discord, Matrix, ActivityPub, Fediverse. So everything we're doing is really geared towards client side, distributed, kind of remote first. And we took the IFC spec, kind of enhancing what WebIFC has been doing, and used a kind of code generation, maybe you could call it AI approach, to automatically generate bindings for the entire IFC spec. So if you are an IFC implementer and you need a tool in-house to do work with IFC, the different versions of it, we have TypeScript bindings. It's upwards of 100,000 lines of code. The IFC spec, we estimate, like version 4.2 or something is what we're on, is something like 7,000 pages of a printed spec, right? So if you put it on, you see, go into architecture offices, they have all those binders. You know, it's like the municipal codes, but kind of the more generic, abstract one for everybody. One of the key problems, of course, with working with IFC is that it's been treated more as an exchange format. And it's kind of big and bulky, and the implementers, I think, Autodesk, Nemetschek, haven't treated it quite right. It's actually pretty good in that it connects back to the entire CAD ecosystem that was developed in the 70s, 80s, 90s. It's line-based, it's source code. We should be treating it like that. Instead of sending around big, bulky imports and exports, we should start thinking like buildings and CAD projects more like libraries that you link together. So a window, just like Antonio's demo, they have a parametric window editor. That window should be like window.ifc, and if you want to include it in a building, like you want 4 windows, then you should import window.ifc and instantiate it 4 times in your building with different parameters, and then link that all together into your building. That's much more where we're going, and that's why you need code bindings to connect all of this to the spec, the IFC spec, and something you can actually compile. To toot our horn a little bit, we saw the performance numbers before. It's hard to follow up Antonio and Creox, especially. We are, the focus so far for those guys has been, once you have the model loaded, how do you show it quickly? So second load, third load performance. We want to complement that with first load performance. So the first time you open an IFC, but we believe that you might be able to, even in a web page, do better than, say, BIM Collab, which those guys are awesome, by the way. The original Web IC project also came out of Tom Ben Diglin from BIM Collab. But we have some early performance numbers that lets us think 860 megabyte file, maybe we could open and begin displaying it. First time seen in a few seconds on a standard laptop. So we'd love to talk more with Creox and Antonio, and we hope to figure out a way to manage this project together so we can all be working together on kind of the best engine for everybody. And that's enough about Bldrs, and I kind of wanted to move on for how this should work together, what we're looking for in the AEC industry going forward for the next decade or so. I sat with Dimitri from Speckle once in London over beers one night talking about IFC. I think this was right before he wrote his blog post of like, yeah, we don't really love it. But I think he saw this analogy, and so I think this is something to consider, is that Right now, the industry is mostly dominated by a few big players. They have proprietary binary formats that are hard to work with in an open source setting. What we should be moving toward is something that's open standards based. On the web analogy to that would be HTML, CSS, XML, all those things. Nobody likes XML and HTML, uses it. If you've lived in that world, there's a great coffee mug. CSS is awesome. Anybody know the CSS is awesome, coffee mug? There's a bounding box around it, and the word awesome goes over the border. Inside joke. Anyway, so those specs are terrible, but they're good enough to get by, and what you really need is coordination. And so we've built the modern web on a spec that everybody used to hate. IFC basically has all the earmarks of that. What we need is semantic definitions of what a building is, and then there's a lot of performance things that we can figure out about how to improve it. GLTF, I think, right? Preox, you guys are doing GLTF display. We would be doing that too. But IFC provides the core semantics. We could plug in municipal codes to that. We're also looking beyond to CAD, the other step formats, AP214 for like 3D printing and automotive. Aerospace, they're all using variants of STEP. IFC itself is just a variant of those specs. They're all defined by ISO. And I think that that's a great, even though nobody loves the world of ISO and all that, that's how we should be thinking, is that the way this ends up working well for everybody is that we're helping develop something like a WebKit, right? So Google and Apple, for a while they were all cooperating on the core browser engine for their different browsers. So Safari and Conqueror back in Linux days. And that goes in and out, there's cooperation and competition. But long-term, what we want to do is move towards a place where we're mostly cooperating on the bottom part of the iceberg, and then the apps are the competition, where you put new cool demos together, but we're not reinventing the wheel, as the phrase has been going. One example of this that has been going now for as long as I've been coding is the Java community process. This is similar to the Building Smart IFC spec development, but I think we need this beyond Building Smart type IFC stuff, more up into the software stack for AEC. So I'd love to see something like, Speckle, that open company, Creox, ourselves working together to develop an engine that could follow some process like this, where we sit together on a quarterly basis, share our roadmaps. This is something that Autodesk did not do sufficiently, and that's what they got dinged on the follow-up open letter to Autodesk. Really put some time into planning on a quarterly, annual basis about how we could be working together in the future. And each one of us kind of takes our thing that we're good at and contributes it. And as long as we play nicely, then the whole community wins. But also understanding that there's room for competition for each one of us to do what we're specialized at. So this is really what I'd like to see, for the AEC industry in general. But instead of those existing players, Apple, Google, the new companies coming up in AEC, for us to collaborate and make that the way that we can change the industry. It's too big for us to change at once. Think of the Code Galaxy picture. There's just way too much work. If we work together, we can accomplish something big. Thanks for listening.